Hi, everyone. Welcome to Azure User Group Sweden. Welcome back after our summer break. So, to those that are watching us live right now on our YouTube channel and also CSharpCorner, welcome. I hope that you're having a comfortable Saturday noontime break, learning and tuning into Azure User Group Sweden. Håkan is not here today, unfortunately, but I'm very happy to be back. And before I introduce you to our speaker and our session today, let me just introduce myself to those that are new in the stream. So my name is Jonah Anderson. I'm the founder and the community leader, one of the community leaders of Azure User Group Sweden community. And we are here today to learn about Azure networking, specifically Azure Virtual WAN, with our guest speaker, Derek Smith. But before I get started and bring him to stage with us, let me just remind everyone about our code of conduct. So we follow a code of conduct that we expect everyone to be nice and friendly. I'll listen with purpose and be thoughtful, be respectful, understand each other, don't criticize, and be curious and open to share your ideas, especially in the live chat. And also, we are going to have an after session like Zoom Fika. And be inclusive in your comments and questions today or during the session. And if you want to learn more, feel free to check out our code of conduct link below. And also, we will be sharing an Azure Heroes Learner Badger for you that are learning with us today. I will show this QR code again later at the end of the session. Feel free to claim it as you learn along the way during the session. And of course, if you want to join us and get a chance to meet Derek, our guest speaker, one-on-one, feel free to join us in a short 15-20 minutes digital fika with us on Zoom and talk more about the topic. So without further ado, let me just introduce our speaker today. So today we have Derek Smith, who works as a Cloud Evangelist at Trace3. He is part of the Cloud and Azure team who engages with clients to help transform their business applications, operations, and initiatives to the Azure Public Cloud. So Derek is very active as a community leader or contributor. He's a mentor, public speaker. He's a real enthusiast when it comes to the cloud. So I'm very happy and I'm honored to host his session today. So let's welcome Derek on the stage. Hi, Derek.
Hello. I should probably
Yes.
update that and like add in the Azure back to school stuff.
Yes. Yeah. Sure. Yeah. I missed.
I'm sitting there going like, I was thinking about it there for a minute. And like, oh, I really should update that. I do the co-hosting for not only Azure back to school, but I work with Dwayne and a few others as one of the co-founders for Gimme Cloud Talks, which will be relaunching next month. So looking
Yes.
forward to that.
And I apologize. I missed
You're
that. I
fine.
was just reading literally,
No.
but I
You're
know.
good.
Yeah.
That's
But
me.
that too.
That's on me to update that. Don't. Yeah, you did nothing
Yeah,
wrong.
no, it's okay. I need to because so here is the I'm gonna send it on the chat, the Azure Back to School. I'm very honored as well to be one of the speakers. So I'll be contributing about Azure Functions and Service Bus. So please
Yeah.
follow that one, that link that I sent on the chat and join us. Feel free to share and learn with a community.
So, yeah,
All
we
right.
got 70 speakers this year. There'll be a bare minimum 2 talks a day. There'll be a few days with 3. So yeah, we had
Yes.
a lot of people submit sessions, a lot of involvements. It's gonna be a lot of fun. Great month of September for learning all fun things about Azure. And as a sneak preview, besides the awesome sessions that you're doing, there is somebody who's going to attempt to answer the question, if Die Hard is a Christmas movie.
Ah, okay. Interesting.
So we'll see.
Don't miss that,
Yep,
everyone. So yeah, feel free to
yeah.
follow Azure Back to School. I think you're using the hashtag Azure Back
Yes.
to
Yeah,
School in
Azure Back to
Twitter and
School.
everywhere.
Yep. Mm-hmm.
Yes, that's great. So just to introduce to the speaker, where are you sitting at right now, Derek? I know that
I am
yes.
currently sitting in a city known as Greenville, South Carolina. It's located on the eastern United States, so down southeast. So if you can find Atlanta and you can find Charlotte, North Carolina, and Atlanta, Georgia, I'm literally right in the middle between those two major cities. So it's kind of nice. So I can drive an hour north. I get to be in Charlotte, drive about 2.5 hours south and be in Atlanta. So yeah, it's a really nice location.
Yes. Welcome. Glad that you could be virtually in Sweden. But anyway,
I technically almost could have been there in person. I was in London
yes,
yesterday. So yeah, no,
yeah,
it wouldn't
yeah.
have been far to hop on over.
Our audience actually are saying hi. Like we have Jose
Wow,
Costa,
Angola,
watching
welcome. Good
from
morning.
Angola, and
Mhm.
he's also saying hi to you. All right.
It's
If we could do this,
evening there. isn't it?
yeah,
Yeah.
I think so. So yeah, we have audience or community members from all over the world. But yeah, without further ado, I'll give you the stage, Derek, so we can
Thank you.
get
All
started.
right.
By the way, I have a question. Do you prefer
Yes.
your questions to be asked at the end of the?
I have a Q&A at the end, but if somebody wants to jump in and ask, I don't mind at
Okay.
all.
All right. Go ahead.
Nobody will be hurting my feelings.
Yeah, sure. You can share your screen. Okay.
All right. Hey, there's that fun little slide. Well, welcome everyone, wherever you are in the world. So good morning, good afternoon, good evening. Thank you for joining me today, and excited to share how we can go from zero to hero with Azure Virtual WAN. As Johanna said, my name is Derek Smith. I am a Cloud Evangelist. I spend a lot of time working out there in the community on top of doing all my fun day job extraordinaire type things. If you guys want to connect with me, you can see my Twitter and Instagram handle right there at Consider Cloud DS, or you can find me on LinkedIn at the lovely web link that you see on your screen right there. Now, with all of that fun stuff out of the way, connectivity in the cloud, right? Networking is literally the foundation of cloud. And the reason why I always say that is without networking, we don't have anything, right? You got to be able to connect to the internet. You got to be able to connect to your various services. You got to be able to connect to your on-prem in like a hybrid cloud situation. So no matter what type of architecture or setup you're going to have, networking is going to be the most foundational piece that you deal with. And for lack of a better term, there are a multitude of different connectivity options, but each of them have their own limitations, and that can make it somewhat challenging to decide which connectivity option makes the most sense for me. Based on those limitations, am I going to run out? Can I scale? So it can be kind of challenging to look at that. There's also some operational challenges, having to jump between different panes of glass to be able to operate the different technologies can be somewhat challenging. And because those views and those glass can be updated and be changed from time to time, it can throw people off. Things might get moved around or misplaced or removed. So there's a lot of operational challenges when it comes to having to jump between various connectivities. And I'm a network engineer by trade. That's where I got my start. And so I can't tell you how many times I've heard from people, if something isn't working, oh, it's the network, right? We blame the network. That's, I think, the number one thing that I've always heard as a network engineer, and even as a cloud engineer and cloud architect, right? Oh, it must be the network. Oh, the VPN's not doing this, or oh, the internet's doing that. Like somehow, some way, it always seems to be the network fault, and that can be very frustrating and challenging, because even though if you prove that it isn't the network, somehow, some way, it still ends up being the network's fault. But what we've seen over time now is we've shifted away from this physical model to a software-defined model, and the cloud really kind of ushered in that era. Some people were kind of playing around with software-defined networking back in the late or early 2010, 2011. But really, as cloud came into being, that's where, being able to programmatically alter our network architecture, our architectural or routing paths became really mainstream. And so there's this huge shift to make sure that you can define your network as code and use software. Gone, well, I won't say gone, but less important are the days to have to worry about going into the specific command lines of your various switches and routers, right? I can just connect to the API of that device, dump the code that I need to, and configure it like it's just any other piece of hardware. And so this huge software-defined shift has created a need to upskill in certain technologies and ditch some of our traditional networking ways of thinking. And then, of course, last but not least, how can we not talk about zero trust? Network security is absolutely paramount. It, by cloud definition, is not the most paramount thing, right? That is still identity. I would be remiss if I didn't say that myself. However, once you pass that identity layer, right, the perimeter layer becomes the next piece. And so we need to ensure that we, as cloud network architects or cloud network engineers, are ensuring that that next layer down is as secure as possible. And we're not just trusting someone because we've seen how that goes. So how do we take all 5 of these things and bake them into one thing? Well, this is where Azure Virtual WAN comes into play. The ultimate vision of Virtual WAN, when it was announced and released, was to bring together networking, security, and routing all under a SD-WAN as a service offering. And so, yes, if any of you have taken the AZ900 or Azure Fundamentals, right, you're told that there are 3 as a services, right? Infrastructure as a service, PaaS or platform as a service, and software as a service. We all know that's not true. There are others. And so networking as a service has really come into its own, mainly thanks to Azure Virtual WAN. And that's exactly what this is designed to be. It is a network as a service. You don't have to necessarily be running anything in the cloud. You can connect on-prem locations, all with Azure Virtual WAN. And I'll show you how to do that. But it leverages the Microsoft fiber backbone, which is one of the largest fiber networks in the world. If you've never checked out the Azure Global Sphere to see all the various fiber cable that is run around the globe and all the different various points of presence, I do highly recommend you check that out. It is a cool little interactive 3D map. Now, when we talk about Azure Virtual WAN and all of the various 5 components that it brings together, we highlight each of these kind of unique feature sets within it. First and foremost is its connectivity. How do we bring about the different connectivity models? How is it ultimately going to scale beyond those limitations, right? So it has a global transit architecture. How do we enable zero trust security? Well, we can deploy security devices into our virtual hubs, which we'll talk about what those are in just a second. And routing. It tends to be the biggest admin overhead within Azure to date. Traditionally, Azure was a static routing methodology. You had to go out and create user-defined routes to go ahead and tell things, hey, I want my next hop to go to this NVA or go out to the internet or head over to this virtual network gateway. And it was very hard to streamline those operations. And so Azure Virtual WAN, with its dynamic routing capabilities, which we'll demonstrate a little bit later, really helps make things a lot easier for you as a cloud engineer or a cloud architect to add in additional virtual networks or on-prem locations without, and then don't have to worry about going and updating a routing table. And then last but not least, we'll talk about how you can integrate third-party network virtual appliances. So if you are somebody who loves like a Barracuda or a Cisco or something of that nature, there are potential options for you to go ahead and integrate those virtual appliances directly in to your Azure Virtual WAN. But let's talk about connectivity and how does it centralize all of our different options? Well, if you're familiar with Azure, Azure has three primary methods of connectivity that we worry about from an enterprise or customer perspective. First and foremost is our traditional site-to-site VPN, IKV1, IKV2, right? I configure a device on one location. I've got a device up in the cloud. I set up my little tunnel and I'm able to communicate with my Azure. What has been the case in the past is that virtual network gateway inside of Azure used to only scale to 30 tunnels. And so that was a huge challenge for a lot of larger enterprises, right? They had more than 30 locations. And so they'd have all these bespoke virtual network gateways in their architecture, and it became a huge headache to manage. And so virtual WAN solves that challenge by being able to scale up to 1,000 connections. I can have 1,000 sites per region, right? So think of a European location. We'll pick on Europe, right? Europe West or EU North, right? I can have 1,000 connections just in that one location. And then maybe I spin up another region over here in the United States, East US 2. I can have another 1,000 associated with US East 2. Okay, so massively scalable and massive amount of throughputs as well. Now, the other method, if we don't want to provide site level connectivity, is that we would give individual users connectivity. And obviously with the pandemic, that became a massive selling point for a lot of organizations. I had to quickly onboard, tens of thousands of remote users into my environment. And so point to site VPN really became a popular option for a lot of folks to connect into the cloud. And so we needed to make sure that that was an option to manage within Azure Virtual WAN. All of the same capabilities as you would find from a site-to-site perspective, except now my VPN client was directly on my laptop or my tablet or whatever personal device I may be using. It supported a number of different authentication protocols. We could stick with IKV2. OpenVPN standard was also available, or we could use our traditional radius or cert-based authentication. So very flexible, and supports up to 100,000 users, again, per region, right? So I could support 100,000 users here in the Eastern United States. I could support 100,000 users over in Australia and continue to add regions, right? So if I'm, say, Microsoft, and I have millions of users all over the globe, this would be an easy way to connect all of them into my backend environment. And then last but not least, we have kind of the penultimate connectivity option, which is ExpressRoute. No organization today doesn't probably leverage ExpressRoute for that private connectivity between their data center and up into their cloud, just from a speed and security frame of mind. So Azure Virtual WAN does support this option with the ability to connect up to 8 circuits per region. So if I needed to provide this high-speed private connectivity model, I can connect up to 8 ExpressRoute circuits in any region that I choose across the globe. Now, there are some strategic partnerships that Microsoft made from a VPN perspective. So if you actually go out to the documentation for Virtual WAN, there are a lot of partners that Microsoft supports, and this is just a small few of them, to automate your site-to-site VPN connectivity. So if I am running, say, a Cisco device or a Palo Alto firewall on-prem, there's actually some built-in automation that I can leverage with those devices in Azure Virtual WAN. So as I deploy various firewalls to my different branch locations, I can automatically spin up and create a site-to-site VPN connection and tunnel it to the appropriate device, automating a lot of my operational overhead. I don't have to go in there and do all the manual steps to configure it, right? Those Microsoft and those partners have worked to make sure that there are scripts and automation available for you to ensure you can get remote sites up and running with little touch or even zero touch. There's a few that have zero touch options, so which, given in today's world, is a very attractive thing for us to have. All right, so I've talked about all these different sites, right? I can connect to Eastern United States, I can connect Northern Europe, I can connect Australia. And we talked about how do we do this, right? So Microsoft has one of the largest fiber networks in the world. And so it uses that very network to connect all of the various hubs. Now, when I talk about a virtual hub, we're talking about a single Azure region, okay? So a hub is equal to an Azure region. So I could have a hub here in East US 2. I could have a hub in Northern Europe. I could have a hub in Norway East, I think is one of the new regions. I could have a hub in Australia Southeast, right? So it's one hub per one region. And with that hub or that region, I can interconnect those hubs and regions over that Microsoft dark fiber backbone, okay? And it does it automatically. So when I create a hub inside of Azure Virtual WAN, and I spin up my second hub, automatically the system will connect the two hubs behind the scenes for you. So I can connect from one region to the other without needing to do anything. And instantly I have my global connectivity. Microsoft refers to this as any-to-any connectivity. I can connect any virtual network or branch or headquarters that I have associated to one virtual hub and automatically be able to reach another virtual hub that may have similar VNets or branch sites or users or HQs connected to that as well, okay? So it helps facilitate each of these various different options, right? Branch to Azure, I can go from one branch location in one region to another branch in another region, okay? I can connect my users to a branch location that may not be in their locale. So maybe I'm working here at my home office in the Eastern United States, and maybe I needed to connect to an office located in, let's pick in France, right? I could spin up my point-to-site VPN and immediately connect to that branch site in France, even though the hub I'm connecting to is here in the United States. So, right, so the massive connectivity option available to us. So how does Virtual WAN facilitate all this fun connectivity, right? This fully meshed environment? Well, it uses a virtual hub router that Microsoft manages on your behalf. So when you create your first virtual hub, what happens in the background is a virtual hub router is spun up that you can't see, but it is there. And there's actually two of them. So there's some built-in redundancy. And it controls all of the routing between the various gateways. So when I create a virtual WAN, which we'll go through a demo a little bit later, you can create either your VPN gateway, your ExpressRoute gateway, or your user VPN gateway, just like you would in normal Azure land. So think of each one of those gateway setups, instead of having to do it individually, I can do it all at the same time inside of the virtual hub router. And so the router will then handle dynamically sending traffic between any one of those gateways, in between the two gateways, or between gateway, and your virtual networks. Now, there is a throughput limit on that virtual hub router. So you can have about 50 gigabits of aggregate throughput per region. So you do need to be careful when you're associating various virtual network connections, right? There is a 50 gig limit. So I don't want to be throwing some massive SAP HANA environment and put it all in one region, right? And expect there to be great performance. So you probably want to geolocate some of those environments out. So I'm not overloading one region with all this SAP work, right? You'll overload the router. So do be mindful that there's a 50 gig limit. So be careful with that. But more often than not, I haven't run into a client who's really kind of tested those limits just yet. Though I think Puma recently became a Azure Virtual WAN customer. And so they might have come into that little limitation. So I'm sure they architected around it. Now, even though Azure Virtual WAN automates our routing for us, we can still go in and create our own custom routes. So those routing tables, even though they do dynamically update, we can go in and add our own bespoke static routes to make sure that we're facilitating more pointed routing. So when you can go in and edit the routing tables, I can add custom static routes to define pointed connections. Maybe I have a web application firewall and one VNet. I want to make sure that as traffic comes in from the internet and hits my virtual WAN, that it then is routed to my web application firewall. And I'm checking for those common web vulnerabilities, right? I don't want any sort of cross-site scripting attacks or file inclusion attacks, anything of that nature. Maybe I have an air gap scenario, right? Maybe there are certain branches that are highly secure, and I don't want users to be able to just automatically remote into those particular branches because they're highly sensitive. So I might define a static route that says, hey, these branches can only communicate with these particular networks, and that's it. Any other traffic that tries to get to these, you're just going to deny it by default. So I can set up, a routing situation with that. Now, what happens from a routing perspective is once I have finished configuring those route tables, both from a dynamic and static perspective, I can then associate those route tables with my virtual network connections. Okay. As it stands today, the route table that is associated to my on-prem connections, and yes, it is associated to all on-prem connections, both site-to-site VPN, ExpressRoute, and user VPN. That is a single table. It cannot be applied at a per connectivity option yet. Hopefully that is coming. I know that's a popular feature request for Azure Virtual WAN, to be able to have an individual route table for, say, like an express route, and then a different route table for maybe VPN. But as it stands today, it's a unified table across all of what they call branch connectivity options. So unfortunately, you cannot apply individual routing to your various on-prem connectivity. Now, just because I can control my routing, that provides at least some level of security, but it's not what I would call great security. And this is where we want to focus on putting a firewall into our virtual hub. And yes, we can do this with Azure Firewall. So we can deploy a Azure Firewall directly into our virtual hub, and it is what's referred to as a secure virtual hub. So we can create a Azure Firewall policy to go ahead and govern what traffic is allowed or denied based on the flow that is coming in and out of the Azure Firewall. And one of the beauties of Azure Virtual WAN is, because of its scale and the fact that we can deploy a firewall in each region, we manage it at scale with the Azure Firewall Manager. So we can apply global policies as kind of a default standard that every firewall must have. And then we can apply regional policies, because maybe my firewall requirements here in the United States might be a little bit different than maybe a firewall requirement over in Australia, or maybe also in Europe. So I can apply regional policies as well. And so it'll take the global policy, inherit those down with the regional, and then combine them and give me a very comprehensive firewall security from an ingress as well as egress situation. Now, there is a current limitation with the Azure Firewall and the Secure Virtual Hub. I can inspect and control traffic in a single region, but if I have a multi-region situation where I've got an Azure Firewall deployed in both virtual hubs, that mesh connectivity that happens between the two virtual hubs is not supported in terms of being able to be inspected. So the team, I have spoken to the product team about that. They are working on it, but as it stands today, it is an unsupported scenario. So do keep that in mind as you're deploying maybe your virtual WAN and testing it out. Secure virtual hub is here. Secure virtual hub traffic is not something that is supported for inspection as it stands today. So, and you can see that listed right here. We can secure our internet traffic and our private traffic like VNet to branch, but not hub to hub. Additionally, there are a few security as a service or SEC partners that can also deploy firewalls into a virtual hub. So currently, as it stands today, Zscaler, iBoss, and Checkpoint, you can deploy their solutions as a firewall directly into the virtual hub and manage them like you would an Azure firewall. So if you're a big Checkpoint customer or iBoss or Zscaler and want to take advantage of some of their additional features or benefits, right, you absolutely can. And you can deploy their firewalls directly into those virtual hubs. And then finally, last but not least, we also have some of our special network virtual appliances. And this typically refers to virtual WAN accelerators. So you can think of a technology partner like Barracuda or Cisco Viptela, right? So being able to support those SD-WAN accelerator scenarios that maybe you are a big Viptela shop and you have a bunch of WAN accelerators all over the place. I can now deploy that directly into my virtual WAN environment and take advantage of those proprietary features that Viptela offers directly in with my virtual WAN. Routing doesn't change. It's directly integrated with the virtual hub router. So from an administrative perspective, I'm not adding any operational overhead to my cloud network engineers or my cloud architects. It's very seamless, no hassle, and I get the advantage of the built-in redundancy that virtual WAN offers. Again, remember, there's a active virtual hub router, so I don't have to worry if my NVA goes down. Great. There's another NVA already active and handling. So it's a very resilient architecture. So putting this all together, again, we have our 4 connectivity options and as well as our security. So we have our express route, our user or point-to-site VPN. We have our traditional site-to-site VPN, and then we also have our VNet connectivity. And remember that we can leverage the Azure firewall inside of the virtual hub and create that secure virtual hub for us. Now, remember, vWAN's biggest selling point is its scale, right? So I can handle 8 express route circuits, 100,000 users per hub, okay? 1,000 site-to-site connections per hub, and I can handle up to 500 VNet connections per hub, okay? And each of those different connectivity options does have a bandwidth ceiling, so you do need to keep those in mind. So for, say, ExpressRoute, you can do up to 20 gigs of aggregate throughput. Point-to-site VPN, you've got 200 gigabits of aggregate throughput. Site-to-site VPN has 20 gigs of aggregate throughput, and then our VNet connections have a 50 gigabit aggregate throughput. So significantly higher than all of our standalone options. If you go out and check out the normal virtual network gateways, you will not see speeds like that on those, with the exception of ExpressRoute. But all the others, right, vWAN is the king in terms of needing that sort of scale as well as that sort of throughput capability. Now, what makes vWAN even more unique is our ability for each of those connectivity options to have very unique features. So for ExpressRoute, you can do site-to-site VPN encryption over our ExpressRoute tunnel. Point-to-site VPN has a built-in traffic manager, so I can manage my traffic depending on where their user is connecting from. It'll automatically route them to the appropriate virtual hub gateway that is closest to them, right? Our traditional point-to-site VPN gateway does not have that capability. Only virtual WAN does. So if I want to have kind of that ephemeral Azure Traffic Manager sitting in front of my point-to-site gateway, I'm going to need to leverage Azure Virtual WAN. We talked about the site-to-site connectivity automation. Again, there's, I think, a list of some 30 or 40 partners out there that Microsoft works with to support automated connectivity of our site-to-site VPN tunnels with those partners. So depending on who you are leveraging from a firewall, on-prem firewall or VPN solution perspective, there's probably some sort of automated connectivity that Microsoft has worked with to enable either zero touch or very little touch setup, which does make it very attractive to leverage those capabilities. And then last but not least, our Secure Hub. Again, we have those 3 partners that are there today that we can deploy their firewall solutions directly into the Secure Virtual Hub and manage them at scale. Remember that the hubs are fully meshed. Even if I were to have 2 Azure firewalls or secure virtual hubs, they're still fully meshed. Just remember that they can't inspect the traffic that goes in between the 2 hubs. That is an unsupported scenario. So in this little diagram I have here, that's why I have the one hub as a non-secured virtual hub, right? So that way my firewall could still inspect my traffic. Azure Virtual WAN supports any number of different routing scenarios, right? So I can go from on-prem to VNet. I can go from my headquarters to a branch location, or I can even go from a user in one region to a branch in another. I can go from VNet to VNet, and I can go from user out to the internet, right? So if I have a Azure firewall deployed inside of my hub region, I can transit the internet, and connectivity is provided that way. Same with a VNet. They can exit out the firewall just like you would in a normal hub and spoke deployment model. And I can also connect multi-region. So if I have a branch location in Australia and I need to connect to, say, some resources that are deployed in a VNet over in the United States, I can absolutely do that with Azure Virtual WAN. All of those routing scenarios, again, most of them are automated for you. And all of the hubs are fully meshed. You don't have to worry about that. There's a number of transitive routing capabilities, but I also have my own custom or static routing options that I can add in there as well that we're going to showcase later. Probably one of the more common questions I always get asked about virtual WAN is, what does its pricing look like? And so there's a couple of different ways to go about that. I don't have the specific numbers up here, but things you do need to take into account are your throughput, and that's based on a scale unit. And so think of a scale unit as your aggregate throughput, and they're in increments of either 1 gig or half a gig. So as you scale up and scale units, right? So that's an additional cost. And then obviously the number of connections, right? So there's a number of connection units, and they're all predefined for you that I'll show you when we go to set up our own virtual WAN. And then if you decide to add in the Azure firewall, obviously there's a cost for adding that. It's not included. So yes, so there is a per hour per gig charge for the firewall. Same thing with the virtual hub. So depending on how much traffic you have going through in and out of that virtual hub, again, you do need to keep that zonal theory in mind, right? So the different net packet charges, right? So whether you're in zone 1, zone 2, or zone 3, so do keep those in mind. And remember, it's egress only, depending on where the source of the traffic is coming from. Okay. All right. So let's take a look at probably the most fun with Azure Virtual WAN, and that is our routing capability. Setting one up is actually rather easy, and I'll show you that in a little bit. But we truly become heroes in Azure Virtual WAN when we master the routing capability. So I've got my pseudo diagram right here. So I got my 3 on-prem networks, and I've got 2 networks up in the cloud, VNet 1 and VNet 2. So just kind of baseline everybody. Now, remember, our routing is dynamic, which is something new for Azure. And so all of my connections up here in Azure can learn routes from the associated route table that we assign. So as I associate a route table to say this connection for VNet 1, it will learn the routes for my branch locations, right? So all of my on-prem as well as VNet 2. I don't have to statically enter any of those routes. It will learn it automatically. Okay, so example right there. So my default route table, it will, if I apply that route table to my 2 connections and it's automatically applied to my branch locations, it will propagate those routes to the route table automatically. I don't have to do anything, and it will learn any new routes that get associated with that as well. So that's kind of what this looks like right here. So you can see I have my site-to-site VPN connection ID, my express route connection ID, my point-to-site connection ID, and then as well as my VNet 1 and VNet 2 connection IDs. Okay, so this is what's referred to as any-to-any routing, and that is the default behavior for Azure Virtual WAN. Now, if I want to maybe control routing a little bit, that's totally fine. I can go ahead and put in custom routes, static routes, right, next hop. So you'll see here that VNets and only VNets can be associated to custom route tables. Again, the branch locations get the default route table by default. So I can create my own route table, give it a name as to whatever I want it to be. Okay, and I can associate it with a virtual network connection. And maybe I've added another virtual network, and maybe inside that virtual network, I have a specific device that I need the specific IP for. Maybe it's a domain controller, maybe it's a network virtual appliance, right? Maybe it's a DNS server, right? Could be anything. So I have that specific IP listed there, right? So this is 10.3.0.5, okay? And so I take the supernet of my on-prem locations, because guess what? There is no associated route table on VNet 3 yet. So I need to tell it, hey, if I'm over here in VNet 3 and I'm on-prem, I need to be able to get to that IP. So I need to specify that if I am in VNet 3, specifically 10.3.0.5, and I need to be able to get to my on-prem, right? I need to use my VNet 3 connection, and I put in my supernet of 192.168.0.0/16, right? So that'll automatically tell Azure Virtual WAN, hey, for any traffic destined for any of these on-prem networks, go ahead and put that on the virtual network connection, right? So I've added that static route into the route table. And vice versa, right? So if I needed to get to 10.3.0.5 and I was in either VNet 1, VNet 2, or even on-prem, and I was trying to reach that 10.3.0.5, right? I can tell the system, hey, the next hop for that is to put it on the VNet 3 connection. So it works both ways. All right. I used a scenario earlier that said, hey, might have some branches that shouldn't connect to each other. Or maybe in this case, we don't want certain VNets connecting to each other, right? We want to air gap them. They're very sensitive workloads. They shouldn't really be communicating any information. Maybe I'm looking to prevent some sort of lateral movement scenario. So I can do that with my routing. I can isolate my virtual networks, okay? So branch to branch is still okay. Branch to VNet is okay, but I don't want VNet to VNet, okay? I don't want my VNets talking to each other. So again, what would that look like? So my on-prem locations would still have that default route table, okay? That's the normal behavior. I can't control that. However, my virtual network connections would get another or a custom route table. My default route table would provide my on-prem connections, as well as connectivity to my virtual networks. However, in my custom route table, I would only define my on-prem connections, okay? So I would only define my site-to-site VPN connection, and I would only define my ExpressRoute connection. I would not tell it where the other VNet lives, right? So remember, default route table is dynamic routing. It'll propagate automatically. So you can see that it has all 4 connections. So I would leave that default route table only for my on-prem, okay? And it would know that, hey, VNet 1 is here, VNet 2 is here on those connections, as well as the corresponding branch locations. But in my custom route table, where I don't have dynamic routing enabled, I would specify that, hey, I only want my virtual network connections to go to on-prem. I don't want them talking to each other. So I would only specify my routes for my on-prem. And now I've effectively air-gapped those VNets. Okay, I would not be able to send traffic back and forth. All right. This is a common scenario, right? Shared services VNet, right? We talk about, or Azure, Microsoft talks about this in a more traditional enterprise scale landing zone type design, right? We put all of our shared services like Active Directory, DNS, you name it, inside of a dedicated VNet. So what would that look like from a virtual WAN perspective? Because virtual WAN is hub and spoke by default, right? But that hub network, we can't put those types of services in there. So we have to put them in another VNet. And so we'll bring back our lovely virtual network 3 with our 10.3.0.0 network connection. Again, our default route table would be completely aware via its dynamic routing of all connections, because we want our branches, I should say, to be able to communicate with each other as well as all of their virtual networks. Okay, but for our custom route table, because remember our custom route tables are not dynamic by default, okay, we have to go in there and specify that we want to know where VNet 3 is, and we'll specify that VNet 3 connection ID and tell it, hey, this is the network that lives there, okay? And if there's a particular, again, just like in my previous examples, there are a particular NBA or some point of entry, we can specify that as well. So we can say, hey, the next hop in order to gain entry into this network is 10.3.0.5, right? So maybe it's some sort of NBA that will handle the routing for us. We would add that next hop IP into our route table entry. All right, let's make it a little more complicated. So we're going to take our isolation VNet example and we're going to make it multi-region. How does that work, right? So I've got 2 regions. I need to isolate my VNets, okay? But I want to isolate them in a way to where, in my example, blue can communicate with blue, but not orange. Orange communicate with orange, but not blue, and can still talk to either on-prem in either region, okay? So this is where now Azure Virtual WAN introduces the concept of labels, okay? So labeling is a great way for us to define particular VNets or locations that contain certain resources. And so I can effectively use them like tags inside of Azure. So if you're familiar with tagging inside of Azure, labels is a similar way. Now our default route table gets the label of default automatically, okay? I can't change that. That's a system thing. So you'll see that the default route table has that label of default. However, I can now create 2 custom route tables, and I can associate the blue VNets with one route table, and I'll label that route table blue, and then I'll label my orange VNet route table, give that the label of orange. So in the future, if I add additional VNets, right, I can just give it a label of orange And so it'll update that route table automatically. So this is how we enable dynamic routing inside of a custom route table, as we use labels. So you'll notice that inside of my blue table, I have just VNet 1 and VNet 3. I still maintain all of my on-prem connection IDs and routes, but I'm only propagating the blue virtual network connections, and then same thing with the orange on the other side. I'm only propagating the orange, okay? And so I associate that label for that dynamic update capability. And then obviously our on-prem locations get everything. Now, this is the default behavior. So I showed you the custom isolation scenario. This is what a multi-region would look like by default if I didn't put any custom route table effects into place, right? So you get that label of default, and then everything would be any to any. I could send traffic to any location, didn't matter where it lived, VNet or on-prem, okay? And it would all dynamically update, okay? So this is the default behavior. Now, let's inject an Azure firewall into this scenario. Okay, what does routing look like with that? Okay, so obviously anything going to the internet, I want to go out the Azure firewall. I want that traffic inspection. If my branch locations are trying to go out to the internet, again, I would want them to go out the Azure firewall, because if I'm paying and deploying an Azure firewall, it doesn't make sense to maintain an on-prem instance of my firewall. So we'll go ahead and make sure that we route our traffic there. And then any private traffic, because remember, Azure Firewall to Azure Firewall instead of a multi-hub region, that's not supported. So I want to make sure I'm directing my traffic, my private traffic, to go direct. I don't want it to go through the Azure Firewall. It's an unsupported scenario. Okay, so default route table, we're going to keep as is. Okay, the exception of I'm going to make one modification to that route table. I'm going to add in the lovely quad 0 route. Everyone hopefully is familiar with that. Yes, 0.0.0.0/0, basically the catch-all, right? If I don't have a defined route for it dynamically or statically, just send it out the Azure firewall, okay? So we're going to put those into our default route table. Okay. And that's all you got to do. Pretty simple, huh? Making it easy. All right. Another common scenario, if you're not somebody who uses an Azure firewall, maybe you have, say, like a Fortinet or a Palo Alto or a Checkpoint or something of that nature, and it's sitting on a virtual machine. Okay. How do I route things through that network virtual appliance? Now, again, those NVAs typically live in one of your virtual networks. So I need to send all of my traffic to the NVA first, and then route it back into my environment. So from a route table perspective, I leave my default route tables alone. And I'm going to make this a little more complicated. I'm going to add in a couple more virtual networks that sit behind those NVAs. Okay. So I've added in 2 virtual networks inside of or outside of VNet 2 and VNet 4. So I'll call them 4A, 4B, 2A, 2B. Okay. Give them some additional routing space. So what I do is I will go in and edit the connection for VNet 2 and VNet 4 that I have inside of my default route table. And I'm going to specify a next hop. And that next hop is going to be the IP associated with either the load balancer or my NVA, right? So depending on your architectural situation with your NVA, if you have a HA pair, right, you're going to point it to the IP that the load balancer is fronting. Or if you have a single NVA, then you're just going to send it to that particular network interface, right? And then on those indirect spokes, unfortunately, this is where you will have to leverage something like an Azure user-defined route table because virtual WAN cannot handle indirect spoke networks, right? It can handle virtual networks that are directly connected, but if they are indirectly connected, then you will then have to leverage something like an Azure route server or a user-defined route to go ahead and specify routing beyond the connected virtual networks. Okay, but you want to make sure that in order to get to that NVA that you edit those connections, right? So in our case, right, we'd edit this VNet 2 connection and this VNet 4 connection and specify that particular IP. Okay. Now I can get creative inside of the route table if just to kind of do a more catch-all, because the route table is going to just pull the connection or the IP address space of the connection ID. So I'm going to get that /24 by default. I can modify it and change it to /16, right, to capture those indirect address spaces. So when you're looking at your route table and you're seeing that, hey, I've got this hub virtual network that has an NVA and there's some connected VNets behind it, make sure that when you're creating your route table that you're taking those into account. So you may need to modify those particular addresses. And so in our case, right, we're taking it from a /24 because that only tells us about the individual VNet, so VNet 2, and then we'll upgrade it to a /16. So that way we include VNet 2A and VNet 2B, right? So we get the 10.2.1 as well as the 10.2.2 networks behind it. Okay, I don't technically have to do that, right? I could do a /22 or a /21, so I could be smaller than a /16, but this is just a demo, so we can be a little more cavalier with our address space. But in a production environment, you'd want to scale that down to be a bit more specific, because in routing world, the more specific route always wins. So you do need to be careful about doing giant supernets. You want to be as specific as you can while still ensuring that traffic is routing where you're expecting it to go. Okay. So, and then you'll see here with this scenario, right, my on-prem can go directly to my bespoke networks, so long as I've got that NVA IP entered into the VNet 2 connection. And then obviously with my user-defined routes, I should be able to go VNet to VNet as well as VNet out to the internet with that network virtual appliance. How do I create a route table? I have some lovely pictures created in here, but I'm going to show you in person. So I'm going to skip by at least that one. But here's a good example of what a static next hop might look like. So this is a route table that I created, and you'll notice that I have my test network connection right here. So my destination type is a CIDR range. I've specified my destination prefix, which is a /24 network, and I've told it that the next hop is that VNet connection ID. So you notice at the very end, I can specify a specific IP. So in our last scenario, if I have that NVA that I do need to send something to, I would just hit that little configure button for next hop IP, and that's where I would put in my static IP entry for the NVA. Okay. We talked about labels. Again, labels are a great way to propagate or enable dynamic routing across multiple custom route tables. Okay, default does it automatically because guess what? The label default is applied automatically by the system for you. So in our blue-orange scenario, as I'm creating my route table, I can associate the label blue to my route table, and then any other custom route tables that I want blue networks to propagate or be a dynamic route, I would apply the same label to that route table as well. And yes, you can apply multiple labels, just like you can apply multiple tags. So you can get creative. So I find people learn this the best way by telling them, hey, it's just like tagging. So as I associate a label with a route table, right, it's the same like associating a VM with a tag. You can do it dynamically. Now, there's a key thing here to understand when I talk about associate and propagate, okay? Association means that the route table allows traffic to be sent from the connections that are getting that association to the destinations that are inside the route table, okay? So association, right? They will learn the routes from the route table that you are associating, okay? Now, my connections can only have one route table. I cannot associate multiple route tables to a connection, okay? So there's a one-to-one relationship between my VNet connections and my route table. I can only have one, okay? Now, propagation, on the other hand, this determines who I want to dynamically enable routing for. Labeling is a great way to do it, to be very granular and very specific. However, in the default manner, or if I didn't care, I can enable propagation. Okay, so propagation allows routes to be propagated from my connection, okay, that I associate the route table with, to all the other route tables or very specific route tables, right? So if I didn't want to use labeling, I can also leverage propagation. However, I have a little less control with propagation. So that's why I always tell people to use labels. But if I didn't want my virtual network connection that I'm associating this route table to share its routing with, I can disable propagation, okay? And once I've done associating all of my various route tables, I can view my effective routes. So that section is right here. You can go in here and see, hey, here are all my effective routes, just like you would in a normal Azure routing situation. So it'll tell me what the next hop type is, what the name of that next hop type or next hop is, what the prefix associated with. If I'm using BGP, it'll tell me what my autonomous system path is as well. Okay. So in summary for routing, okay, on-prem, so my site-to-site, point-to-site, and express route connections, right? They are all considered branch spokes, okay? So they will always get the default route table and the label of default, okay? That is a system function. You cannot override that. Custom route tables. Yes, I got my little message that we're running a tad bit late, so I'm sorry. Custom route tables are only supported for virtual network connections. Hopefully, the product team is going to make custom route tables available for branches sometime soon. I'm crossing my fingers for that. But as of it stands today, you can only do that with VNets. Okay. Now remember association. Okay, a connection, a VNet connection's associated route table is where that VNet will learn routes from that particular route table. So whatever routes I have in that route table that I associate to, say, my VNet 1 connection, okay, VNet 1 will use the routes in that route table only. Okay, so a one-to-one relationship. Okay, and then propagation. Okay, so I can tell my VNet connection that I associate the route table with that if I want to propagate my routes, okay, I can either do it via labels and associate my connections with, or my route tables with different labels to propagate via a label, or I can do it with the propagation feature and say, hey, I want this route table to learn about routes from VNet connection 2 or VNet connection 3 or branch VNets. Okay, so there's two different ways to do it. Propagation, a little less granular. Think of it kind of more broader scope. Labeling, again, I can be very controlled, very specific. Specific route always wins. Okay, can't tell you how many times I've run into a situation where a customer was setting up all their route table and they used very broad supernet situations, and routing loops galore happened. Okay, so make sure you're being very specific, okay, or as specific as possible when it comes to using your routes. Okay, If a /23 will get the job done, use a /23. Don't use a /20 or a /16. Okay. So be as specific as you can. Okay. If you have something like an Azure firewall that you want to force tunnel all of your traffic to, remember that is a static route. The catch-all 0.0.0/0. Okay. So you need to put that in there. Otherwise, the system will not do it by default. Okay. You can view the effective routes on the route tables. So if you'd like to make sure, hey, I want to go check my custom, virtual network route table and make sure that everything is going where it should, I can do that. You view the effective routes just like you would in normal Azure land. And then last but not least, if you do not want your route tables to propagate to anything, there is a special label that I'll tell you about. This is a secret. Well, it isn't a secret. It's just a less known thing. So maybe I have a secured virtual network and I don't want it to propagate my routes to anything. I don't want anybody to kind of really know about it. There's a label called none. Okay. So I can put that label on one of my custom route tables. I can associate that custom route table to that particular virtual network that I don't want anyone knowing about. And with the label of none, you will not propagate any routes. So I can use that virtual network to get to the various services that I need to, but it will not share any of its routes with anyone else. Okay. So it's a nifty little secret to where if you have a particular sensitive virtual network and you don't want anybody knowing how to get to it, right? Effectively create a black hole, use the label none. So that's what I refer to as the routing label of death. All right. Action items for you. If you want to learn more, go spin up your own Azure Virtual WAN. There's a lot of awesome GitHub demos and repos out there. I've included the link to one of my more favorite ones. So that GitHub address is up there. There's also a Azure Virtual WAN micro hack out there on GitHub if you want to leverage that. So if you want to, if you enjoy open hacks and you've gone through maybe one or two of them, there is a little micro hack for Virtual WAN out there, so you can do that as well. And if you couldn't tell, as I was joking with Johanna earlier, that I needed to update this deck just a tiny bit. Action item number 2, you can learn more through some of these certification trainings. However, as we all know, AZ303 is dead. That's gone. And AZ104 is now kind of the branch for that. However, what AZ104 covers from a virtual WAN perspective is incredibly minimal, if not non-existent, in my opinion. It literally says, hey, this is virtual WAN. Here's kind of the high level of what it does, and it's very basic, and that's it. So what I tell people now is just go to the AZ700, okay? The AZ700 is specific for Azure network engineering, and you get a ton more content and depth to learn about. So just go straight to that. I included the link to that in our little chat, so we'll drop that in there. But go check out the AZ700 exam learning path on Microsoft Learn, and you can learn a whole lot more about Azure Virtual WAN, as it's obviously core component. And then just to summarize all of this up, just to kind of remind you, Azure Virtual WAN is that ubiquitous connectivity, routing, and security in a completely unified framework. Okay, so connectivity, security, as well as monitoring in one giant circle. All right. Since we went over time, I unfortunately don't think I'm going to have time to jump into the live environment. But if you stick around in the Fika,
yes,
I will do that. I will go into my live environment and I will show you what virtual WAN looks like.
Yes. Hi, Derek. Thank you so much for the great session. Thank you.
Mm-hmm.
Oh. Hi. Can you hear me? Yes.
Yeah, I can hear you.
Thank you. Thank you for the great session. It was like I like the interactive graphs and diagrams that you did. I think I'm gonna rewatch this recorded session and like do my notes as a as I plan to take the cert as well for the AZ 700 maybe one of these days. Yes, we have actually a lot of questions from our
Okay.
audience. I waited till this section, and first question that we have is actually from
Okay.
Asar. He asks, do I still need VNet peering between VNets if I have used Virtual WAN Hub to connect to multiple VNets and on-prem locations?
No. So virtual WAN is a hub and spoke architecture by default. So if you have VNets that are connected to your virtual WAN hub, you do not need to peer them. Okay. So treat the virtual WAN hub essentially as your hub network. You have to provide the virtual hub an address space when you create it. So you'll assign it some /24 address out of your address pool. Okay. And when you establish those VNet connections, it's essentially like peering it. So yeah, no, you don't need to peer any virtual networks that are connected to the virtual WAN hub. You can do the transitive routing automatically, which is what makes it fantastic because it's automatic instead of needing to set up a bunch of user-defined routes.
Yes. Thanks for that, Derek. We have another question from Nikolaus. He's a friend and contact of mine in Sweden. So
Okay.
he's asking, is Express Route safer than site to site when it comes to ransomware attacks? In which side of the network should I put sensitive data to keep it safe, regardless of other defense techniques?
In my personal opinion, okay, so I'll give you my personal opinion, then I'll give you kind of the practical or the Microsoft answers. I'll put the quotes. My personal opinion is yes, express route is safer. And the reason is because the express route is not on the internet. Okay. You're not exposing that traffic to the internet, potentially get sniffed. Now you can make it even extra secure because virtual WAN allows you to build a site-to-site VPN tunnel, right? An encrypted tunnel over your express route. So you can have your private connectivity and have encrypted tunnel on top of your private connectivity. So that would be what I would do if you have super secure data. Now, the Microsoft answer is you can use either. But I know a lot of security folks who don't trust traffic going over the internet, even if it's encrypted. So yeah, if it's highly sensitive, I would do express route with a site-to-site VPN tunnel built over it because you're getting the benefits of private, that it's not sniffing the internet, and you're getting the benefits of encryption in transit.
Yes, that's great. Nicholas said, thank you. Yes, all right.
Thank
More
you.
questions. This is
Yep.
interesting for our audience, actually. We have another question from Anthony. I had read that you can stand up multiple hubs in Azure region to address some scalability concerns. Any concerns or gotchas?
So here's kind of the gotcha. Yes, you can stand up multiple hubs in a single region. The problem is they're all in different Azure virtual WANs. That's the only way to get around that limitation. It's one hub per one region. So if you need to have multiple hubs in a region, you have to spin up multiple virtual WAN instances. So that's how you get around that limitation. The problem is, I guess to use this as an example, if I needed 18 express routes going into East US 2, so I'd have 8 express routes in one instance of my virtual WAN, and then I'd have 8 express routes in another instance of my virtual WAN. Those two instances of virtual WAN don't talk to each other. So they are effectively separated from a networking perspective. So that's the other kind of gotcha and limitation to that is your first 8 can all communicate with each other, but the subsequent 8 won't be able to talk to the first 8 and vice versa. So yeah, that's kind of the gotcha with that. So there's a way around that limitation. It can get very hairy very quickly, for lack of a better term. Obviously, there are ways to architect around it, but it can become very difficult to manage. I've only run into that scenario once, and it was with a client who wanted to treat ExpressRoute as like a way to provide a service, which I don't recommend, and not even Microsoft would recommend. ExpressRoute is really meant to be dedicated to you and you alone, for high speed, data center or headquarters type connectivity. If you need to provide your customers with a service that you're supporting in Azure, I would use ExpressRoute not ExpressRoute, sorry, site-to-site VPN, because site-to-site VPN can go up to 20 gigs as well, right? And that uses 1,000. So there's a much better scalability option with that.
Okay, more questions. Actually, we have 2 more from, let's see. I think they are important, interesting questions as well. So even if we're out of time, let's take it.
No, that's fine.
We have 2 from Azure. If I have configure one virtual WAN hub, do I need to worry about the single point of failure?
No. So no. So yeah. So the virtual hub, when you spin one up, it is deployed in active mode by default. So the virtual hub router that gets spun up behind the scenes that you can't see, there's actually 2 of them. So no, it is not a single point of failure. You actually get 2 instances. So yeah, if one fails, there's another one already running and active. You can connect to it at any time, or you can divide your connections. So yeah, no, there's no single point of failure.
Okay, another question, same guy.
No, that's fine.
Yeah, lots of questions. Interesting. Can we define UDR between VNets? I thought UDRs can only be associated with subnets inside VNets.
You are correct. So yes, UDRs can only be defined inside of subnets. You would only use UDRs from a virtual WAN scenario is if you have indirect virtual network connections. So in my example, I had VNet 2, and then there was VNet 2A and 2B. So from a VNet 2A and 2B perspective, on the subnets that I had in there, yes, I would list user-defined routes to route traffic to virtual network 2 where that NVA lived. So yeah, it would still be at a subnet level. I unfortunately was speaking in kind of a high level term and saying VNet. So I am sorry for that confusion. Yes, you can only assign UDRs to subnets, but yeah, it's only for indirect spoke connections when you have a virtual WAN architecture. Otherwise, use the route tables. Because of those dynamic capabilities, you're going to find your life much easier versus having to manage a bunch of user-defined routes.
Yes. The last but not the least, someone asked, this might be something else. Someone asked, can you give a free RDP giveaway? I don't know how to answer that. I'm not sure. Can you give it away? I don't think so, right?
Unfortunately, no, I can't.
No, it's not free. You have to pay the cloud.
Yeah, I think he's referring to, Microsoft used to offer what was called a basic SKU, which was like a free, free site-to-site VPN tunnel. It can only have like 10 connections. It was really low speed. That actually SKU has been deprecated and eliminated. There is a basic virtual WAN SKU, but that basic SKU is just it only enables site-to-site VPN. It still costs money to run it. You just don't have access to things like ExpressRoute and point-to-site VPN and some of the other features of virtual WAN. So there are 2 SKUs, basic and standard, but yeah, it's not free, unfortunately. Yes. And even the old one is gone. So if I were to spin up like just a traditional virtual network gateway in a VNet, I can't select basic. It's gone.
Yes, actually, it wasn't the last. There's someone that just posted this. Yeah, you can read it, right?
I can.
You see it. Yeah, you see it.
If so, what would be the process? This would be a really long-winded answer. So here's what I'm going to tell you. There is a great document on Microsoft Docs in the virtual WAN area that goes over this exact scenario on how to migrate from a traditional hub and spoke VNet architecture to virtual WAN. So go check that document out. It's great. I've used it at least a handful of times. Bastion hosts, this is kind of where it'll get just a tad bit tricky. It's still supported, But obviously, you'll have to take your Bastion host out of the hub network because you can't deploy it in a virtual WAN hub. You would have to deploy it into a spoke VNet. The good news is because of the routing, you will still be able to get to all of your other virtual networks. And so Bastion host is still capable of reaching those. But yeah, it goes into a spoke network instead of the hub, unfortunately. So that's the only caveat to that little scenario.
All right. Thank you. That was the last.
So
yeah, thank you so much, everyone, for staying with us through the past hour and also raising last minute questions. It's been interesting. So feel free to follow Derek and his social media, Twitter, LinkedIn, and website, as well as maybe I think you can share, Derek, about your upcoming course regarding this topic. I think it's coming soon, right?
It is coming soon. I was actually working more on it on my plane flight back from London to here. But yes, no, I'm excited to be working on the AZ700 for LinkedIn Learning. So my first course for that, which will be kind of a exam overview in two facets. So this kind of first course will be a refresher to prepare you to take the exam. So if you've already done all of the requisite kind of learning and training, it'll be a great way to go in there, get a refresher, being like, yeah, I understand this topic. Here are the objectives that I need to know and understand. So it'll serve as kind of a good gate check before you take the exam. And vice versa, it'll serve as a good gate check to be like, am I ready to actually take this course? So if I'm talking about certain subjects that you're probably scratching your head being like, then go and take the AZ104, maybe do a few other things before you dive into the more focused, dedicated sessions that I'll be working on later. But yeah, so that course should be out here in the next couple months, which I'm super excited about. And then obviously we'll work on building out the full AZ700 learning path. My good friend, Carl Cook, is helping me out with the course. So you'll see both him and I doing different sections inside of there. So yeah, I'm super excited. I love working with Carl. He's great. So yeah, stay tuned.
Yes, thank you so much. And thank you for your time, Derek. I know it's very early your time today. It's like 4 a.m., 5 a.m. And then your dog.
It was 5 a.m.
Yeah,
he's fine. Yeah, no, he's fine.
We heard him in the background, and I told others that he just want to say hi, just like my dog sometimes. But anyway, before we are late for the fika, but we will still join the Zoom meeting if you want. Just if Derek has the time, so feel free to say hi with us. But before I end the stream, let me just share this QR code again to claim your Microsoft Azure Heroes Learner Badger. And here is the link to our Fika, bit.ly URL, and Azure Sweden Fika. So thank you so much, everyone. And I hope to see you on the next 15-minute meeting short after the session. I hope that you have a great weekend. Thank you so much, Derek.